Welcome to the lamest disco of 1979. This whole thing is powered by one of the first electronics kits that I ever put together back when I was a teenager. This is called a color organ, and what it does is, as you saw, flashes lights to the beat of the music. This particular one has three different channels that it can flash lights on based on the high, mid, and low frequencies, and then it's got a master gain control or master level control on the front, and you can adjust how sensitive each of the three lights is. And for this demonstration, I was just running it off the audio amplifier that I built from a kit last fall? Something like that. It's a neat little kit. I'll put a link to that kit there. This one here. The box is separate. That's just something that I made with my 3D printed parts and a couple of laser cut parts. But that's not important. You could use any audio amplifier with this because the speaker output of it is what goes into the back of our color organ here. It doesn't take a line level input. It needs a speaker level input, which is a little bit odd in this day and age, you'd think, but well, that's just the way it was done back then. You may have noticed, if you've been watching for a few years, that now and again stage lights or stage lighting related stuff shows up on the channel. I don't do that professionally. I did kind of amateurish do it a little bit back 20-30 years ago, just to help out community theater and local bands and stuff like that. But I never really did it professionally, and I was always intrigued with it, as witnessed by the fact that I was building things like this back when I was a teenager. So I thought, since I discovered this again, rediscovered it in my closet underneath a whole bunch of layers of junk, I thought I would take a look at it and just refresh my memory on what the circuit is and bring you guys along for the ride. So there's the kind of quality I was doing back in, I said 1979 or thereabouts. All the parts for this came from a kit, and I had to supply the wire and the case, but everything else was something that was in the kit. I don't know what that bit of plastic is that I used for an insulator down there, but at least I had the good sense to do that. Although I didn't show entirely good sense. Notice the auxiliary fuse here. Oops. Let's just pretend we didn't see that, shall we? To take this board out, really the only thing that's holding the board in is the nuts on the potentiometers, and the potentiometers are soldered onto the circuit board. So I'll just crank these off, pull the board out, and then we'll take a closer look at it. It's not that complex a schematic. It really isn't. So with those out, I should be able to just slide that guy out here. And let's see how bad my soldering was back then. Yeah, pretty bad. I was using probably the whatever solder I could get from the local hardware store, and my grandpa's soldering gun. Yes, not an iron, a gun. And this board that came in the kit looks like it was probably hand itched by the Jana company, which was an electronics company in Winnipeg back in the day. This board was a product of 1976. The TCCO-23 was their part number. I doubt very much you're going to be able to find anything on the web about that. They ceased to exist around the mid-80s, I think, because electronic kits were starting to become a little bit passé, or at least in this area they were, I suppose. It was a pretty small market. So the audio comes in on this wire here from the back, which is speaker level. One side goes through that capacitor, and then both sides go over to this transformer, which is how it isolates the audio amplifier, the audio input, from the AC main stuff. So you don't have to worry about blowing up your dad's Victrola while you're discoing out in your bedroom. And after that transformer, the audio just goes to three capacitors here, which have resistors associated with them. That creates a really minimal filter to get your high, mid, and low frequency audio. Then we have these potentiometers that are part of that circuit as well, and it goes to the gate of these 3 triacs. And that is it. I think I probably should draw this out for you. What was my little bit of plastic? I think that's out of the bottom of an ice cream bucket. I just hacked it out. Actually, it looks like I melted it out with a soldering gun. Wowzers. As expected, that didn't take too long because, as I mentioned, it is a really simple little circuit. So we have the speaker audio coming in over here through a capacitor. What is that capacitor? Looks like it's a 220 microfarad, okay. After the capacitor, it goes to the primary of the transformer, straight to the secondary. So the speaker audio is completely isolated from the rest of the circuit, which is good because the rest of the circuit is live at mains voltage. The secondary side of the transformer goes across the 10K master pot, and the wiper from that goes down to one end of each of the 3 frequency selecting pots, and then the other end of those pots is just all common and back to the bottom of the transformer secondary. And then each of the 3 circuits is exactly the same with slightly different value of capacitor and resistor in there to create that filtering effect. So the high frequency circuit has a 1K series resistor and a 22 microfarad capacitor that goes to the gate of the SCR. I thought they were triacs, but no, they're SCRs, specifically TIC 106B SCRs. That also is why this works much better with incandescent lights than with LED bulbs. It is only giving half of the wave out to the thing in the first place, and some LED bulbs really don't like that. Plus, it's coming on at random points in the audio waveform or of the sine wave based on whatever the audio is doing. So a lot of the newer LED bulbs just won't work with this at all, which is why I had incandescent bulbs connected to it. So from the gate to the cathode, we have a 5.6K resistor there just to give it a little tickle of AC on that side. And then we have the cathode side just going out to the AC output plug. These here. And that switches it, and then we have common AC to all 3 of them on this side, going out to the AC input, going in from the AC input, and then the AC through the fuse, which I have got bypassed on this thing because I was young and dumb, I guess, and that goes to back to the anode side, no, to the cathode side of the SCRs. And that is all there is to it. But as I said, this is probably the second kit that I put together. The first kit that I ever put together is this one, which is exactly the same thing, only it's 1 channel's worth. And the circuit inside there is even simpler because it's only 1 channel, but it is, other than that, pretty much the same. There's the transistor, there is the pot. This one's got an AC switch on the back of it. We have 1 capacitor, 2 resistors, resistor, capacitor, resistor. Exactly the same thing. It's a slightly lower powered SCR on there, and there is no fuse, but other than that, yeah, it is the same basic little circuit. You could, of course, put in additional channels and filter it if you wanted 4 channels worth of dimming or of flashing, but typically back in the day, any of these that I saw, even the commercial ones, almost always were only 3 channels. Even in the big bar shows and whatnot, where the DJ was using a color organ, it would just be the same 3. I'm sure it was a much more professional schematic, but yeah, this was early days of automated disco lighting. I hope a few of you found that as a nostalgia trip, and the rest of you found it interesting and yeah, an interesting trip down memory lane. Well, thanks for watching. I appreciate you tuning in. As always, questions or comments down below. I'll talk to you later.